question is waveform of V naught of t shown in the circuit below is. Here the clock duration is 2 milliseconds, means it attains plus 12 volts first 1 millisecond, and next 1 millisecond it takes minus 12 volts. Okay, so suppose if Vi is equals to plus 12 t in between 0 to 1 millisecond, this is the first cycle, minus 2 rows, it is in between 1 millisecond to 2 millisecond. Similarly, it repeats for 3 to 4, 4 to 5. In that manner, it is going to repeat. So, if Vi equals to plus 12 means the transistor is going to turn on. So, transistor is in on situation. This is zero point 0.1 microfarad. So V naught is nothing but voltage across the capacitor. So in the steady state position, the capacitor acts as a open circuit. Open circuit means in the steady state position, Vc of t is nothing but 12 divided by 12.1 k into 0.1 k, which is equals to 0.1 volt. 0.1 volt means 0 to 1 millisecond, the amplitude of the output voltage is 0.1 volt, which is a constant, as this one. Okay, now if Vi is minus 12 volts, then the turns transistor turns off, means it acts as a open circuit. So the Vc of t is nothing but 12 into 1 minus e power minus t by RC. Here RC is the time constant, that is 12 into 10 power 3 into 0.1 into 10 power minus 6, which is 1.2 milliseconds here. But the duration of the input waveform, which is having a minus 12 volts, is only for 1 millisecond, but the time constant is 1.2 milliseconds, means it needs more time to charge towards the minus 12. So after 1 millisecond it's going to attain again plus 12. When plus 12 means the output is going to be 0.1 again. Hence the duration of the charging period of the output waveform is only for 1 millisecond, that is 1 to 2 milliseconds. Hence output waveform is C. Option C is correct.
Enhancement of reactive power in percentage of shunt capacitance and shunt inductance when operating voltage of system is increased by 20% and frequency of supply is also increased by 20%. Now what is reactive power? I can write reactive power as V squared by X. If you are having capacitance, okay, here he placed shunt capacitance. Now what is X value? I can replace this one as 1 by omega C. Now this is V square into omega C. Suppose if you have an inductor, now what is this reactive power? V square by, it is replaced by XL. Okay, I can write here Q shunt capacitance is equal to, it is directly proportional to V square into F, since omega is equal to 2 pi F. Similarly, Q shunt inductor is directly proportional to V square by F. Okay. Now what he said, voltage is increased by 20%. That means I can replace this V is equal to 1.2 times of V2 is equal to 1.2 times of V1. Okay, now what is Q shunt capacitance 2 here? Is equal to Q shunt capacitance 1 times, okay, into V2 by V1 whole square into F2 by F1. Okay, where V2 is equal to 1.2 V1, F2 is equal to 1.2 F1. If you calculate this one, okay, this is 1.2 V1 by V1 whole square into 1.2 F1 by F1 into Q shunt capacitance 1. Okay, you will get around 1.73 times of Q shunt capacitance 1. What does it mean? That there is 73% increase in reactive power if voltage is increased by 20% and frequency increased by 20% in shunt capacitance. Now what about shunt inductance? Okay, Q shunt inductor 2 is equal to Q shunt inductor 1 into V2 by V1 whole square. So this is 1.2 whole square into F1 by F2. So this is 1 by 1.2. Okay, this is 1.2 times of Q shunt inductor 1. What does it mean? That 20% increase in reactive power for inductor. So answer is 73 and 20 respectively. So option A is the correct answer.
Consider a joint ensemble XY, PXY of A2, BZ equals to 1 by 12 for Z equals to 1, 2, 3. Then conditional probability, that is P y by x of B3 by A2 is, here B3 A2 is nothing but probability of A2 B3 divided by probability of A2. Here probability of A2 B3 is nothing but 1 by 12. Probability of A2 is nothing but J equals to 1, 2, 3 A2 BJ, which is nothing but 3 into 1 by 12, that is 1 by 4. Hence probability of B3 by A2 1 by 12 into 4, that is 1 by 3. Hence option C is correct.
Of frequency scheme permits the slip power flow in both directions. Okay, and machine can be controlled in both subsynchronous and supersynchronous speed. Okay, he has given two types of drives here. One is static Cramer drive, another one is static Chebyshev drive. Static Cramer drive is only used when speed is less than synchronous speed, that is called as subsynchronous speed. Okay, similarly, static Chebyshev drive, okay, we have it for both less than synchronous speed and greater than synchronous speed. Okay, what does it mean? That subsynchronous speed, this one is supersynchronous speed. So option B is correct answer. Of dielectric is, okay, see here, we know that power factor of a dielectric is sine delta. Okay, dissipation losses is given as V square omega C into tan delta. This tan delta is called as dielectric or dissipation factor of dielectric. So option C is correct answer.